Hey guys, wanted to show you here the severe weather threat in the plains. Contrary to popular belief, we do love you guys in the plains, and we do look at your weather and we talk about your weather. And this is looking like an impressive event shaping up here in the plains. And I'm going to start here with the surface dew points and surface pressure map. And for those new, I always like to look at this as a starting point. It's a method that I learned from Joe Bastardi, working with him at AccuWeather, and he learned it from Dr. John Kerr, who used to be the head of the Earth and Mineral Sciences, dean of the Earth and Mineral Science Department at Penn State. So it's kind of a nice way to start, narrowing your search down, and it works very well actually. And what that is you look for high dew point air in pressure areas under, well, you can use 1012. 1008 is where the real ideal stuff starts, but 1012 is also a good part to look at too. Now, what I learned from 60 or above is the ideal. However, having taken Dr. Forbes for synoptic meteor at Penn State, he usually used 57 or 58 dew point. And of course, that's not listed here, but this yellow shading here is your 55. That's your 55 dew point air there. And your orange here is your 60 dew point air. That's 60 in there. So, in between there is going to be, where your 57, 58 is. So, we will use for now, we'll use the, just below the 55 area here. And so right in here is where your high dew point air is going to be, just inside there like that. Now there's your dew point, and now here is your 1012 millibar in here. This is 1012 in here, and this here is 1008. So you have a lot of high dew point air in that area there. Now we want to look at the low level jet and the wind directions as you go up through the atmosphere. And here's 925 millibars and a very, very strong low level jet, obviously, through this area. Nice southerly low level jet, nice low level flow coming right out of the Gulf of Mexico, bringing a lot of moisture in on a strong flow like that. Looking at 850, and again, very strong jet. But I want you to notice here something that's happened. Look at this jet here, seven the knot low level jet, 60, 50 knot jet all the way down into here at 850. But look what's going on here. Look at the difference here. Here's our 925 millibar. It's almost due south. Then we go up to 850 millibars, and now it's starting to come out of the south-southwest, even west-southwest up here. So we're starting to see that directional shear shaping up, and you'll see that as you go up even higher. Here's 700 millibars, and not as much of a difference. But wait till you see here 500 millibars. It's basically west-southwest. So now we've gone from the surface of 925 millibars, we had a southerly wind. Here at 850, we have a west-southwest wind. And that is the type of thing that produces tornadoes. That's the type of thing that gets the atmosphere spinning in a given area. And that is a very impressive shear there as you look through it. I'm going to show you again here from 925, 850, 700, 500. And that is just very, screaming shear there going up through the column. And here's our 300 millibar. And here's our trajectory here. But I want you to notice here what's going on here. At what you want to see here is divergent, and here it is. Here's the winds going here, and there's the winds going there. So there's your divergence, and there you get good ventilation for the storm tops to grow up through the atmosphere, and so it's very good setup there. And this here, looking through all that, it's this area in here that I think is going to be the biggest target, and our best threat for tornadic activity should be somewhere in here, I think, as it looks now, maybe down into northeast Texas a little bit more. But that's where the main area is going to be. We'll look here now at this is the vorticity 500 millibar vorticity. You see a nice shortwave coming into that region. So not only do we have surface lift with the front coming in, but we have good upper level lift as well with this vigorous shortwave coming across. Also a very decent vertical velocities at 700 millibars, adding additional lift into this region. So we have all the ingredients here. We have the moisture, we have the lift, we have the shear. Yeah, we have everything we need for a good severe weather outbreak. Here's our CAPE values, basically in the 750 to 1500 range, and that not extremely high, but certainly with all the other factors, that should be sufficient enough. And here's our EHI, which will tell you the amount of spin. Now, here's the SPC's outlook. What I think will probably happen is this slight risk is going to be expanded a little bit more like that, and we're going to see a moderate risk pop up probably somewhere in this region here. Is what I'm thinking we're going to see happen as we go forward with this event, because there's a lot working for this event for that to happen. So that's what I'm looking for with this particular event here. There are very nice ingredients that are going to come together, and this could be a pretty decent severe weather outbreak. If this was June and these dew points were a little bit higher, we'd probably be talking about a newsworthy severe weather outbreak. But this is going to be pretty impressive in its own. So that's what I wanted to show you. I am meteorologist Jim Rinaldi, and have a good day.